In this video, we are going to revise some questions from Mathematics Paper 2 for the year 2018. And this paper was written by the external. So let's look at question 6 here. The diagram below shows a beam in form of a frustum with square ends of sides 4 centimeters and 10 centimeters respectively. The height of the beam is 9 centimeters. Then the question is find the volume of the beam. So we have been given the frustum, and this frustum was made from a pyramid here. So there are some points that I want us first to have in mind here is we know that the two bases, the below one and the above, they are of squares. So what this means that all the four sides are equal. If this is 10 centimeters, this is also 10 centimeters. Then also this is 10 centimeters and also 10 centimeters. So also it is true for the lower one. So here we have 4 centimeters, here 4 centimeters, then also here 4 centimeters, also 4 centimeters. Now, after knowing this, we have two ways in which we can find the volume of this frustum. The first one, we are going to find the difference between the volume of the large pyramid and the volume of the smaller pyramid. So let's deal with now finding these two volumes. So we'll first begin by extending these lines so that we can form or make our frustum into the pyramid. So now we can see that the height of this frustum is given is 9 centimeters. Then from here plus the one that we've added, this one will just say we'll have x centimeters. So for us to find the volume of these two pyramids, first we need to find the value or the height of the smaller pyramid. So let's begin by this. So the pattern is the height of the smaller pyramid divided by the height of the large pyramid is equal to, since we are dealing with the squares, we'll say the length of the smaller pyramid over the length of the large pyramid. Then what is the height of the smaller pyramid is just x. Then the height of the large pyramid will be x plus the height of the frustum, so that is the point. So x plus the given height is the height for the large pyramid. Then length of the smaller pyramid is 4 centimeters, so we put 4 here. Length of the large pyramid is 10 centimeters, so we have 10 here. Then we cross multiply, so we know that our 10 multiplied by x giving us 10x. Then here we are going to have 4 times x will give us 4x plus 4 times 9 will give us 36. Then we can collect the like term, so 4x will go to this side. So here we have now 10x minus, this will become minus 4x is equal to 36. Then we can now subtract 10x minus 4x will give us 6x is equal to 36. Now, for us to solve for x, we can divide both sides by 6, even here by 6, so that we have now the value of x is equal to 6 into 36 will give us 6. So this simply means that the height here, the value of x is 6 centimeters. So now, what is the height of the large pyramid? So this one will be 9 centimeters plus 6 centimeters, which is 15 centimeters. So we have now this picture here. Now let's find the volume. So the volume now will be volume is equal to 1/3. Then we are going to have L, capital letter L squared for the large pyramid times h minus small letter L times small letter h. Then let's do the substitution. So the length of the large pyramid is 10 squared times the height, we have it 15, minus the length of the smaller one is 4 centimeters squared times 6. Now let's expand and simplify. So we know that 10 times 10 is 100. So here we have 100 times 15 minus 16, which is we have 16 times 6 here. Then if we multiply 100 times 15, we have 1,500. Then 16 times 6, I'm getting 96 here. Then we can subtract 96 from 1,500. So I'm getting 1,404. Then we can now divide by 3. If we divide by 3, my answer is 468 centimeters cubed. So this is our volume. Now let's also find another way, but this time there is no need of finding the height of the smaller pyramid. We just use the given 9 centimeters. So the formula is volume is equal to 1 over 3 times h, which is, we can just say h over 3, open brackets. So say area 1 plus area 2 plus the square root of area 1 and area 2 as a product. So now these two squares, we'll consider one to be area 1 and the other one to be area 2. So it doesn't matter which one is area 1, which one is area 2, the answer will always be the same. So let's consider the upper, this one, as our area 1. Then the one on the bottom will be as our area 2. So what is the formula for the area of a square? So a square is equal to, since the sides are equal, it's just L times L, or L squared. So we know that the area 1, we are dealing with the square, the big square with the length of 10 centimeters. So this will be 10 centimeters multiplied by 10 centimeters. So we know that if we multiply 10 times 10, it will give us 100. Then centimeters multiplied by centimeters will give us centimeters squared. Now let's also solve for area 2. Area 2 also is a square, so it's L times L. This time our length is 4 centimeters times 4 centimeters. So 4 times 4, we have it is 16 times squared. Then let's do the substitution. So the height, the value to put on the height, this time we are just going to use the 9 centimeters, the given 9 centimeters from the question, which is 9 centimeters here. So we have 9 centimeters over 3. Then area 1 we said is 100 centimeters squared plus area 2 is 16 centimeters squared plus, then here we are going to have 100. You can just ignore the centimeters squared, since centimeters squared times centimeters squared will give us centimeters raised to the power 4. The square root of centimeters raised to the power 4 will be centimeters squared, so we can just ignore that. So we can now divide 3 into 9 centimeters is 3 centimeters. Then 100 plus 16 is 116 centimeters squared plus. Then 100 times 16 will give us 1,600. So we need to look for the square root of, so the square root of 1,600, this should be 40. So we have 40 centimeters squared Then we can add. So 40 plus 116. So I'm getting 156 centimeters squared. Then 156 multiplied by 3, I'm getting 468 centimeter times centimeter squared, we have centimeters cubed. So we can see that we are getting the same values. Okay, so now we move on to question 7 from section B. Then we have question A in the diagram below. A and B are points on latitude 60 degrees north, while C and D are points on latitude 60 degrees south. Then given pi is equal to 3.142 and radius 37. Roman number 1, calculate the distance BC along the longitude 60 degrees is in, not comma. So we are finding the distance along the longitude. So the formula is distance is equal to theta divided by 360 2 pi r. So we don't add cos here, or if we want we can say distance is equal to theta over 180 pi r. So where is this coming from? So what we've just done, we've just cancelled 2 into 2 is 1, 2 into 3 is 180. So now when finding the distance in along longitude, we need to find the difference in latitude. So let's look at the latitude for B is 60 degrees north, then for C is 60 degrees south. So we need to add here. So 60 plus another 60 will give us 120. So we can now proceed. Distance is equal to 120 over 360 times 2 times 3.142 times the radius is 37. So let's do now calculations. So 120 times 2 times 3.142 times 37. So I'm getting 2,591,772.96, not commas. Then you divide by 360 here. So that's our distance. So if we divide by 360, so I'm getting 7,199.4, not commas, as our answer. Then you can round it off to 3 significant figures, but the answer is this one. Now let's also find the same distance, but we use now theta divided by 180 pi r. So distance is equal to, the theta is the same, 120 over 180 times 3.142 times radius 37. So what's our distance? So let's do calculations. So 120 times 3.142 times 37. So I am getting 1,295,886.48, not commas. Then divided by 180. So let's divide by 180. So I'm getting the same answer, 7,199.4. So the point here is you can use any of these two formula, so the answer will always be the same. Now let's move on to Roman number 2. Roman number 2, a ship sails from C to D in 12 hours. find its speed in knots. So the formula for speed is equal to distance over time. So time, we have it 12 hours. So the task here is we need to find the distance. Now, which distance and where is it lying? So we are calculating the distance along the latitude of 60 degrees south. So this will be theta 2 pi r, then we add cos x. So whenever you are finding the distance along the latitude, you add cos x. Then we need also to find the difference in the longitude. So the longitude for D is 60 degrees west, then for C is 60 degrees east, so we add. So this will give us 120. So distance is equal to 120 times 2 times 3.142 437. Then cos the latitude where these two letters are is 60 degrees over 360. So let's do now math. So 120 times 2 times 3.142 times 3437, then cos 60 divided by 360. So I'm getting 3,599.7 nautical miles. So now this is our distance. So distance equal to 3,599. Then we divide by the time is given 12 hours. So now, so we say 3,599.7 divided by 3 by 12. So I'm getting 299.975 knots. So if we round it off, we get 300 knots if we just round it off as a whole number. Okay, so now we move on to question 7b, Roman number 1. Determine the equation of the normal to the curve y is equal to 2x squared minus 3x minus 2 that passes through the point 3, 7. So we have been given the curve for a parabola and the point. Now the key point, we are finding the equation of the normal. So the equation of the normal is the same formula, so which is it's y1, just y minus this should be so it's y minus y1 is equal to gradient open bracket x minus x1. So we know we have the pair for the coordinates, it's 3, 7. So we have the x1, we have it, y1, we also have it. So the point, what we need here to find is we need to find the gradient of the normal. So how can we find a gradient of the normal? First, we will find the gradient of the curve at this point. So how can we find the gradient? We need to differentiate this equation. So it's y is equal to 2x squared minus 3x minus 2. So we are going to find the first derivative of this equation. So the first derivative is, first we are going to differentiate. So this 2 will be here. So if we bring down our 2 times 2 give us, so 4x minus The derivative of a letter raised to the power 1 is just 1, so we have 3. Then the derivative of a constant is just 0. So gradient is equal to 4x minus 3. Now, from the first pair of the coordinates, the x value we have been given is 3, so where there is x we put 3. So this will be 4 times 3 minus 3, which is giving us 4 times 3 is, this is giving us 12 minus 3, which is our gradient is 9. So according to my calculations, my gradient is 9. Now, this is the gradient of the curve and the tangent. And remember, at a point of contact, the gradient of the curve is equal to the gradient of the tangent. But for the normal, we say the normal is perpendicular. So what we are going to do is, for the gradient of the normal, we need to make this one as a fraction. So what we are supposed to do here is, we can use the formula m1 times m2 is equal to -1, but the easiest way is, if you have a whole number like 9, then the gradient of that for the normal will be 1 over that number, which is 9, then also the negative, so this is our gradient. So we have y minus y1 is 7 is equal to, our gradient is -1 over 9, x1 is 3. Now, so that for me to have some spaces, first we are going to get rid of the fraction, so multiply by our denominator 9. So this 9 will first multiply by, say, y and 7. So 9 times y is 9y. Then 9 times 7, I'm getting 63. Then 9 times -1 over 9 x minus 3. So this will cancel, giving us -1 x minus 3. So 91 minus 63 is equal to -1 times x is -x. -1 times -3 is +3. Then we can shift this number to this side. So we are going to have 9y is equal to -x plus 3 plus 63. So 9y is equal to minus x. 63 plus 3 is 66 over 9 over 9 over 9. So our final answer is y is equal to -1 over 9x plus 66 divided by 9. Says we can just leave it like that, so we can just say 66 over 9. So this is the equation of the normal. Now, after finding the equation of the normal, let's look at how we can evaluate. So evaluate, we have the inside function x squared minus 2x minus 3. Then we are evaluating from 0 up to 1. So here what we are supposed to do is we need to integrate. So let us integrate. So x squared, so you add 1 to the power, then over the same thing, so over 2 plus 1 minus 2x. This x has a power of 1, so this is 1 plus 1 over 1 plus 1. Then what happens to the constant? So the constant, you just multiply by x, so 3 become 3x. Then evaluating from 0 to 1. So let us see if we can simplify it. So x raised to the power 3 over 3 minus, here we have 2 over 2 x squared minus 3x, evaluating from 0 to 1. Then we can cancel this one. If we cancel, we have x raised to the power 3 over 3 minus x squared minus 3x. Then evaluating from 0 to 1. Then upon reaching here, we need to make two brackets. So say x raised to the power 3 over 3 minus x squared minus 3x. This one will be evaluated using 1 minus x raised to the power 3 over 3 minus x squared minus 3x. Then we'll evaluate with 0. Then where there is x, we put 1, so it's 1 over 3. We know that 1 times 1 times 1 is 1 over 3. Minus here we have 1 squared is 1, minus 3 times 1 is just 3. Minus, let's go into this one. So this one will just give us a 0, because 0 to the power 3 is 0 divided by 3 is 0, minus 0, minus 0. So here we can see we have 1 over 1, so that we can find the lowest common denominator. So the lowest common denominator here is 3. 1 into 3 is 3 times 1 is 3 minus, 3 into 3 is 1 times 1, here should be 1. 1 into 3 is 3 times 1, 3. 1 into 3 is 3 times negative 3 is negative 9. Then 1 minus 3 minus this one, so this will give us negative 11 over 3. 3 into 11 is 3, remainder 2 over 3 units squared. So whenever you see these intervals, this indicates that you are dealing with the integral where the definite integral where you are calculating the area. So when finding the final answer, you ignore the negative sign because there is no negative area. So the negative is just indicating that this area is located on the negative part of our Cartesian plane. So now we move on to question 8a. 3 villages A, B and C are connected by a straight path as shown in the diagram below. So given that AB is equal to 15 kilometers, angle ABC is equal to 79 degrees, and angle ACB is equal to 40 degrees, calculate Roman number 1, the distance AC. So we are solving AC. So let's first indicate the angle with its corresponding distance. So this angle corresponds to this distance. So here we have small letter B. Then this angle here will correspond to this, so we have small letter C. Then our hair will go here, then we have small letter A here. Now here we are not told if we are going to use the sine rule or cosine rule. Now how do we know that we are using sine rule or cosine rule? So we need to look at what we have here. So from the data from our triangle here, we can see that we have 2 angles and 1 distance. So whenever you have 2 angles, 1 distance, and the question is asking you to find the second distance, use the sine rule. So the first letter here is, if we are looking for the distance, so we are going to say it's B, which is the distance that we are solving for, since the AC is on distance B, over the sine of capital letter B. So this is our first pair. Now when choosing the second pair, make sure you select the pair where you have the distance and the angle. So you are going to choose C over sine C. Why? Because we have the distance for C and the angle for C. We can't use A since we don't have the distance for A. So let's now continue. So we have B over sine. What is the angle of sine B? So the angle of sine B we can see is 79. So sine 79 is equal to, then C, the distance for C is 15 kilometers over sine 40. We cross multiply, so this will give us sine 40 degrees B is equal to, here we are going to have sine 79 times 15 kilometers. So we divide by sine 40 over sine 40. So let's find our, so we say sine 79 times 15 divided by sine 40. So I'm getting about 22.9 kilometers. So this is our answer. So this means that the distance here is 22.9 kilometers. If we were to round it off to the whole number, this is the same as or approximately as 23 kilometers. So we have found the distance. Okay, now let's look at the now let's move on to Roman number 2. Roman number 2, we are looking for the area of triangle ABC. So area is equal to half. Now the two distances that we are going to use here, we are going to use B and C, since these are the two distances that we have. So this will be half BC, then sine the angle. Which angle? We are going to use angle A, so sine angle A. Why are we using angle A? Since the reason why we are using angle A, the two distances C and B are the ones forming angle A. Now how can we find this angle A? Since we have the other two angles, we are going to add the other two angles, then we subtract the total from 180. So 79 plus 40. So if we want to show our working, we can do this. Let me find some space of it. Let me use. So you can say we are finding angle A plus 79 plus 40 is equal to 180. So angle A plus, so 79 plus 40 is giving me 119. So 119 is equal to 180. Then if this 119 shift to the other side, so will be 180 minus 119, which is our A is equal to, okay, so I'm getting 61 degrees here. So this is our angle 61 degrees. Now since we have our angle 61, so this is the angle that we are going to use. So our now calculation will be area is equal to half times the distance for B is 22.9 kilometers, then times for C 15 kilometers, sine the angle which is A 61. So let's do now math. So it's 22.9 then 15 sine 61. So I'm getting 300.431869 kilometers squared over 2. Now let's divide by, so divided by 2, I'm getting my final answer as 150.2 kilometers squared. So this is our final answer. Now let's look at the shortest distance from B to AC. So the distance that we are trying to solve is this one. So here, so the shortest distance, the formula for shortest distance is equal to 2 times the area over B. So 2 times what's our area? 150.2 over, now the base is the distance for AC, since we are moving from B to AC. So where the line is touching is the distance for base, so which is 22.9 kilometers. So if we do mathematics, so times 2 will give us this divided by 22.9. So I'm getting 13.1 kilometers as our shortest distance. Okay, so now let's move on to question. So question B here, we have solved the equation. So cos theta is equal to 0.937. Then so the point here is, since the cos is positive, we are going to solve two angles. So we want to find two angles for cos where cos is positive. So cos is positive in the first quadrant and the second quadrant. So we can first find the first angle. So shift our cos to this side, giving us theta is equal to cos of this number 0.937. So what is this angle? So shift cos 0.937. So I'm getting 20.4 degrees. So this is our first angle. Then the second angle, since our cos is positive and the range is between 0 up to 360, we are going to solve for the other quadrant, which is in fourth quadrant. Cos is positive in the fourth quadrant, so that angle, we say angle A will be equal to, so you say 360 minus the angle in the first quadrant, so minus 20.4. So what's our A? So if we subtract this, we get 339.6 degrees. So these are the two values that we were looking for. Now let's look at C. Sketch the graph of y is equal to sine theta for. Okay, so we need let me see the space that I can use. Okay, let me just see how I can manage this space. So whenever you are trying to sketch, you need to draw the x or y plane. Now in the x axis, we put the angles, so 0, 90, 180, then 270, 360 here. So we have 1, -1. So let's see if we can make the table values. So theta, then sine theta. So what is the sine 0? So sine 0 is 0. What is sine 90? Sine 90 is 1. Sine 180, this one is 0. Sine 270, this one is -1. Sine 360 is 0. So we have a continuous wave, but since we have been given where to end, we'll end from 0 up to 360. So let's now plot. So 0, 0 is here, 90,1 is somewhere here, 18,0 is here, 27, -1 somewhere here, 360,0 is here. So this is the sketch of the side. So this is how you make a sketch. Okay, so now we move on to question 12a. Express 3 over 2x minus 5 minus 4 over 3x minus 3 as a single fraction in its lowest term. So we have two fractions and we want to combine the two to make a single fraction. So let's begin. So we have 3 over 2x minus 5, 4 over x minus 3. So we first begin by finding the lowest common denominator. So the lowest common denominator is just 2x minus 5 in brackets and x minus 3 also in brackets. Then we divide 2x minus 5 into 2x minus 5, x minus 3. So 2x minus 5 will cancel with 2x minus 5, giving us so the 3 will multiply with x minus 3, minus 4 here. Then if we do the same, if we divide x minus 3 into x minus 3 times 2x minus 5, this x minus 3 will cancel with x minus 3, giving us 2x minus 5. Then we can expand the upper part. So 3 times x will give us 3x. 3 times 3 will give us 9. Then negative 4 times 2x will give us negative 8x. Negative 4 times negative 5 will give us positive 20. Then we can collect the like terms. So 3x minus 8x minus 9 plus 20. So this will give us 3x minus 8x is 5x. Negative 9 plus 20 will give us positive 11 over 2x minus 5, x minus 3. So this is our final answer. Now let's move on to the other question. Question B. So for question B, the diagram below shows the graph of, so we have a cubic function that has been plotted for us. Then let's look at the questions. So let me first zoom out. So let's look at the questions here. Now the question is, use the graph to solve the equations. So the equations, the first equation is, we have x raised to the power 3 plus x raised to the power 2 minus 12x is equal to 0. So what we are going to do is, we need to compare this part here. So we are going to compare this part here with our original equation here. The question is, are these two the same? So if they are the same, then if they are the same, we need to say y is equal to, we need to replace x raised to the power 3 plus x squared minus 12x with y. So we know that y is equal to 0. So how do we get the solutions whenever we have y is equal to 0? So y is equal to 0 is the x-axis. So we are going to get the solutions from the 3 points where our x-axis is cutting or meeting with the curve. So the first point is here, the second point is here, the third point is here. So the first value, I can see that our first value of x is equal to negative 4. Then the second one, x is equal to 0. The third one, x is equal to 3. So whenever you have the 0, you just have to consider the intersection, the intercepting of the curve with the x-axis. Now let's check for B. So B, we also have it is x raised to the power 3 plus x squared minus 12x is equal to x plus 10. So let's compare this part here with this one. So it's the same. So this will give us y is equal to x plus 10. So as long as after you found that, after you compare and you found that they are the same, you remove the first part and you equate to whatever that comes after equal sign. So we are dealing with a linear equation, and our linear equation here is y is equal to x plus 10. Now we are going to find the x-intercept and the y-intercept. So let's solve for y. So in solving for y, we know that when solving for y, x will be 0. Since in the y-axis x is 0, so where there is x, we put 0 plus 10. If we do the math, y is equal to 0 plus 10 is 10. So we know where our line will pass through. So in the y-axis, our line is going to pass through 10. Now let's solve for y. So if we put 0 on the y, this will give us 0 is equal to x plus 10. Now if we can see that this time we are going to get negative, this will give us negative 10, and we don't have negative 10 in the x-axis. So let's change. Let's not use it. Let's say we use okay, let's change it. So sometimes you start from 0. If 0 doesn't give you the points that are within the curve, you try to change. So let's say we use x is equal to 5. Let's say x is equal to 5. Let's solve for y. So y is equal to x plus 10, which is y is equal to 5 plus 10. Y is equal to, so we have 15 here. So we have this number. So let's check if y is equal to 15. Now what can be the value of x if y is equal to 5? So the same coordinate that you use for x must be used for you to solve for y. So we know that the equation is equal to y is equal to x plus 10. Now 5 will also not fit. Oh, 5, okay, 5 can fit. We can use 5, that's okay. So that we put 5 here is equal to x plus 10. Then if we collect the like terms, will be 5 minus 10 is equal to x. So our x is equal to negative 5, since we have negative 5. So it's y positive 5 comma that one. Can we use 5? So 5 comma, okay, so we are going to use this. So let's plot. So it's negative 5 comma 5. So negative 5 comma 5 is 1 2 3 4 5, somewhere here. Then we go to the other one. The other one is x5 comma 15. So 10 15 is somewhere here. So we need to draw a straight line. So you are supposed to use the arrow. You need to draw a straight line passing through those 2 points. I have missed. Let me see how I can do my best, my very best. So the key point is, after integrating these 2 points, you are supposed to draw a line touches on those 2 points. So now after doing this, we can now look at where this line, our linear equation, is touching with our equation, which is our curve. Then we need to come down in the x-axis. So this is where we are getting the value. So the first value, according to my estimations, these are just estimations. Okay, since I'm not using the rule, so I'm getting about negative 3.7 as my first x value. Negative 3.7, comma. Then the other x will be gotten from here. So negative 0.8. Then the other x is here. So 3.5. Then let's go to the other question. So the other question we want to calculate an estimate of gradient, and we have also been given the x coordinate for that point or where. So there are two ways in which we can find the gradient. So first we are going to use the tangent. So we need to draw the tangent at where x is equal to -3. So where x is equal to -3, so where x is equal to -3 is here. So if we are to find the value of y, so y is 18. So we know that our y will be 18. Okay. Now let's draw a straight line, a tangent. A tangent is a line, a straight line that touches a curve or a circle at one point only. So this is our tangent. So we have this point, so we can get another point of our choice so that we can find now the gradient. So let's choose which point can we choose. So we'll take this point here. This point is -4, comma 13. So let's solve for gradient. We know that gradient is equal to y2 minus y1 over x2 minus x1. So we'll consider this one x1, x2, y1, y2. So y2 is 13 minus y1 is 18 over x2 is -4 minus -3. So gradient is equal to 13 minus 18 is -5 over, here we have +1. So if we divide, we have gradient is equal to 5. Okay, let's also find another gradient, but this one let's differentiate. Let's use we know that we can find the gradient at this point using the first derivative of a given function. So let's differentiate. Y is equal to x raised to the power 3 plus x squared minus 12x. So let's find dy over dx is equal to 3. Our 3 will come down here. This will become 3x, 3 minus 1, which is 2, plus if we bring our 2 here, this will be 2x, 2 minus 1 is just 1, minus the derivative of x raised to the power 1 is just 1, which is 12. So we can now say gradient is equal to 3. What is our x? So the x coordinate is -3 squared plus 2. What is our x? -3 minus 12. So m is equal to 3. Here we have +9, -6 minus 12. So gradient is equal to, here we have 27 minus here, what is -6 minus 12 is that is 18. So what is 27 minus 18? So 27 minus 18 is 9. So this is the actual gradient. So the derivative will give us the actual gradient, but if we use the estimation here, this is just an estimation. That's why there is calculate an estimation. So the estimation gave us the gradient of about 5. Then the derivative gave us the gradient of the value 9. Now let's look at what are we supposed to do. So what are we supposed to do now? Let's look at the area. So area bounded by the curve where we have been given where we want our curve. Let me see what I can grab here. So if you want more of these lessons about cubic functions, you can write in this comment section below so that I make more of these. So we want to find the area bounded by the curve. The first one, the curve, then number 2, x is equal to -3. So we need to draw a line where x is equal to -3. Then we also have the other one, x is equal to -1. So x is equal to -1 is here. Then y is equal to -10. Y is equal to -10. So where y is equal to -10 is this line here. So this means that we want this region here. This is our area. Why? This area is the first one bounded by x is equal to -3. The second one, x is equal to -1. Then y is equal to -10, and the curve is bounded by the boundary. So let's look at, we can find the area of one complete box here. So what are we going to do? We need to look at the shape here. So let's look at the interval from the y-axis. So from the y-axis, we can see that it's 0, 10, 20. So this means that they were using a scale of 2 centimeters to represent 10 centimeters. But in the x-axis, we have each distance is 1. Then y, it's 10. So the area for one box will be area is equal to L times B. Then area is equal to, our L is 10 times our B is 1. 1 is the 1 unit in the x-axis. So if you multiply 10 times 1 will give us 10 units squared. So this is the area for one complete box. So let's look at how many complete box do we have. So we have 1, 2, 3, 4, almost 5. So multiply by 5, which is giving us, this is 5 times 10 is giving us 100 units squared. Then for this one here, which is not that complete, so this can just be an approximation. So this is same as just instead of 10 can be about so you can count the smaller boxes, then divided by 100, then we have our area. So this is about 0.7 units squared. So if we add, we have 100.7 units squared. So this is how we can find the answer. So that's it for this video. Thanks for watching.